Okay, I'm going to start with just playing my demo. And so I have the simulation implemented, so if I just press H, this is the bomb right here, the missile was up there, and you can see on collision the text showed up and the music started playing. Okay, so now moving into the actual code, I'll start with the visitor pattern. So for the visitor pattern, the way this works is that every game, we use this for collision in particular, so for every game object, it is a collision visitor, and since it's a collision visitor, it has to implement these methods, which are the response for when a collision event happens with a particular other game object. And the real purpose behind the need for this visitor pattern is that when a collision event happens, we essentially need to figure out what are the two game objects that are involved. And in order to do this, we use a sort of double dispatch with this visitor pattern. So what happens is on a collision, which is detected by the collision pair in this collide method, on a collision, if the two game objects do intersect, we will call the accept method. And what that's going to do is, so if in particular for the collision pair, game object A will accept game object B, and then in that accept method, game object B will call game object A's visited by. So essentially what's going to happen is if game object A is a bomb and game object B is the shield, then we will end up calling game object, so we'll call the bomb dot visited by the shield, essentially, if that makes sense. But so basically through the double dispatch on an event, we call the accept and then we call the visited by. We're able to get the types within the method. Within this visited by method, we can have the two concrete class types. And so that should cover that. Moving on to the factory. I still haven't implemented it the way that you would like, Ed, but I plan to look at what you. I can't implement yours with the switch statement. It just bugs me too much. So when I see you remove that, I'll probably refactor my factory. But for now, my factory, I can go up to here. So my factory is a singleton, and when I call create shield, it instantiates the singleton, also creating the shield and everything to do with it. So this is all I need to do is just give it the position, and it'll create the entire shield. And so if I go to that, you can see when I create my shield factory, it'll initialize the sprites and textures and images associated with the shield. And then in this create shield method, I've enabled the function to dynamically build the shield, so I can be given an arbitrary number of columns, essentially more or less an arbitrary number of columns and rows, and I could build any shield type, just involving some constraints on it. But in order to do this, I build it in parts, so I build the left side, the right side, and the center separately, and just based on the same start Y. And so that's how I'm doing that here. To create so here's my actual creation of the game objects. I still have the individual functions that will be called for each one, and they're passed the necessary data in order to create the actual object. Okay, so moving on to my flyweight. The flyweight pattern, the way I've complicated mine a little bit in order to enable multiple fonts to be used. So the way mine works is I have this font manager, and it manages a collection of fonts. And these fonts hold a collection of glyphs, that make up the actual font. So it holds the glyph manager, and the glyph manager holds the actual manages the actual glyphs. And so each font is the font type, the file, and the set of glyphs. And then the sprite text manager, which is the interface the user would interact with, it is able to create a font. So you can call this create font method to create a new font, and then when you add when you want to create a new text, you give it the text name, which is just an identifier, you give it the message, which is what you want it to be, and then you give it the font. So given a font, we can create a sprite text that will use that font. And the sprite text essentially just holds a reference to, based on that name, it finds the font and holds a reference to it, and will write the glyphs making use of that font essentially. And that's basically how mine works. Moving on to the sound manager, I simply just wrapped it around. I have a wrapper around the sound engine. When I create my sound manager, I also create all the sound resources, and at which point I also have this enum right here, which it maps to the index in the array. And so in order to play a sound, all I do is just I'm passed in the enum, I cast it to an integer, and that maps to the index in the array. And so the user can either pass me the enum, or they can just call the function, which will knows the enum type. Okay, so moving on to the way the observer system works. In particular, for collision is where we're using the observer right now. Here's that except method I had mentioned before. But essentially, the way the observer works is I attach observers onto a collision pair when I create the collision pair. So you can see I have the message observer and the sound effect observer right here. And yeah. And then so when a collision happens, when they intersect, I'll call this except. And what'll happen is if node B is the bomb group, we'll end up in the if node A is the bomb group, we'll end up in the except, and then if node A is the bomb group, if node A is the bomb group, we'll end up in bomb groups except, and then that will then call visited by on the shield in this particular demo. And when you're visited by, so we'll end up in this method, and it'll essentially just relay, delegate to the column and then to the shield bricks. And so when we get down to the shield brick, it'll be a visit between the bomb group and the shield brick. And so we'll unwrap that and turn into a visited by the bomb and the shield brick. And so right here, this is where the triggering of the actual observer happens. So we just call notify listeners, and that'll notify all of the listeners that are it'll delegate to this method, and it'll notify all the listeners that are attached to the subject. And in this case, the collision subject is attached to a collision pair. You can see right here. So that's what the notify listeners is doing. And then so that's going to end up triggering each of the observers, and then the observers will just execute whatever behavior they're supposed to. Okay, so I'm being lazy and I forgot to explain how the Flyweight font system is different than memory pooling, object pooling. And the way they're different is essentially because we're not actively removing the glyphs from the font or font manager, however you want to look at it. But rather they're created on startup or whenever you want to create the font, and they remain static or constant throughout the rest of the lifetime, or at least that's the idea behind them.